Good morning, sir. Good morning, sir. Please go ahead, sir.
Let us start today's session 1. The topic is hydropower station and overview. The guest speaker is Dr. S. Christian Johnson. So today I feel happy to introduce the guest person to talk about this topic. Dr. S. Christian Johnson. He began his career as a lecturer at Mumbai in a college called as Bharat Vidyadeep's College of Engineering, and he acted as postgraduate trainee at National Aeronautical Laboratory (NAL) Bangalore during 1991. Okay, so and he has involved in the fabrication of India's prestigious light combat aircraft also. And in the year of 1992, he joined in Tamil Nadu Electricity Board, and later it was turned as Tamil Nadu Generation and Distribution Corporation, which is called as Tangitco. And he worked, it is under the state government of Tamil Nadu. He worked for a period of 20 years there. Okay, and he acted as, finally he acted as senior manager, head civil for Hydro Training Institute. And he got voluntarily retired, and he worked for various engineering colleges as dean, and currently he is working as dean academics at Erode Sengundar, director academics at Erode Sengundar Engineering College. And again he is having membership in a lot of professional bodies like ICI, ISTE, and another highlight is CIGR, CIGRE, CIGR. So as a member of CIGR, that is International Council on Large Electrical Systems, he has traveled to many foreign countries and hold a post of secretary honorarily. And he has worked in many groups involved in that professional body. And currently he was guiding research scholars also. He was expert in corrosion activities, and he wrote about 6 textbooks. He published around 22 articles in national and international journals, and more than 25 papers in conferences. So that's all about him. So I kindly request Dr. S. Christian Johnson to take over the session. So good morning, Dr. S. Christian Johnson, sir. Good morning, Johnson, sir. Good morning, Johnson, sir. Having some connectivity issue. Let me see now. Yes, Dr. Christian Johnson will be joining now. Yes, Christian sir. Johnson sir. Can you hear my voice? Your voice is audible, not audible here.
Yeah, is it audible now?
Yes, it was audible. So welcome, sir.
Welcome. Thank you, sir. Thank you so much.
Okay, I have introduced you. You can start the session now.
Okay, thank you. Okay. Very good morning to all the participants. I am very glad to speak to you regarding the hydroelectric power and its overview this morning sessions to the students, participants. The outline of the session is I would like to explain the meaning of hydropower and what are all the stations which are available in the country and how these hydropower plants are classified based on various parameters and advantages and disadvantages of hydro schemes. Also, what are the various civil structures which are associated with the hydropower plants. In addition to the civil structures, there will be some other mechanical structures also, including electrical components here and there. I will be just using those terminologies also over there. And now we will see what is meant by hydroelectric power. Hydropower is one of the cheapest electrical power that is being generated across the world. It is otherwise called as water power, which is deriving energy from the falling water from greater heights or through storing such water in a reservoir, utilizing the static head which is available in the reservoir and the elevation head also. The electric power is generated for driving the machineries. In the earlier days, hydropower was very much utilized for water mills, sawmills, textile mills, dock cranes, and domestic lifts. This is how it started. If you want to know about the little principle in this generator, see, if you take a coil and just rotate in a magnetic field, you know that electricity is generated like a cycle dynamo. So in order to get the electricity, you have to rotate a coil in a magnetic field. This is done in the hydropower stations by means of driving the turbine using the energy which is available in the flowing water. Thus, when the energy of flowing water is used to run the turbine, the electric power is generated, which is otherwise called as hydroelectric power. The hydropower stations which are installed for generating electricity is called as a Hydel scheme. The power station is generally known as Hydel power stations or hydroelectric power station. If you look at this cross section of the hydroelectric power generator, see, look at this. This is the main shaft, which the bottom portion is having the turbine. Turbine, it's a typical diagram cross section of a generator coupled with the turbine. So here you see this is a generator area where you have got the rotor coil, and then this is the stator coil, it's a stationary one. And the rotor coil is the rotational one. So once you rotate this coil, you concentrically inside this stator, there will be power generated in the stator, and that is trapped. So in order to realize this rotation, this mechanical energy is utilized by means of driving this turbine. So once by means of water which is flowing somewhere else, so if it is entering into the tail vents and then passing on and driving this turbine and falling away. Okay, once it is done, the shaft is rotated. So this is a simple principle in a hydropower station. So this is in which we have used one typical type of turbine called a Kaplan turbine, and there are different types of generator, different types of turbine. Based on that, mechanically and electrically, the hydropower generations are classified in different front. In a hydropower scheme, a certain quality of water at a certain potential head is essentially utilized when it is flowing through the turbines. So when the water is flowing through the turbines from a source, there is a head, the water head, which causes flow, and in turn it drives the turbine blades, and then it rotates the rotor in the generator, producing electricity to the generator coupled to the turbine. If you look at this diagram, this is a cross-section of a typical hydroelectric dam coupled with a dam house. So if you look at this dam, this is a cross-section of the dam, and you see this is the toe side of the dam, and this is the hill side of the dam. So in the toe side of the dam, this powerhouse is constructed, and the water which is stored in the reservoir is allowed to go through a pipe called a penstock, and then it is allowed to just go through this spiral case, which is a concentric one, and through the inner circle of this spiral case, water will be entering into the sharp vertical draft tube, where the water leaves, and then through this tube it leaves the turbine area. So this is a downstream. This is the upstream part, and this is the downstream part. This is how a typical hydroelectric dam, a simple hydroelectric dam, which is based on a dam, is functioning. So now we'll see a small formula which governs the hydroelectric power. So if you note on this formula, where this electric power in terms of kilowatt is equal to the turbine and generator efficiency eta multiplied by the density of water. In terms of kg per cubic meter, that is 1000 kg per cubic meter, and then this is the acceleration due to gravity g multiplied by the head. Okay? From what height the water falls below. Okay, any particle, because of its position, it has some energy. So any particle which possesses energy because of its position is called as potential energy. So the potential energy will increase as the height increases. When it is coming down, the potential energy also will come down. Then this component multiplied by how much of water per second it is flowing through the turbine. That we call as discharge. So in this formula, it is mentioned as flow rate. So this is the formula which governs the hydropower in any hydropower stations across the world. So in this, there are two variables. One is this head, other one is the discharge. So depending upon these two parameters, from what height the water comes, how much of water quantity is leaving the turbine, flowing through the turbine. So depending upon that, it varies from place to place, station to station. So depends upon these two parameters, and this power is determined. So these two things are constant. This rho and g is the density of water, and g is constant. But the turbine and generator efficiency is supplied by the manufacturers. Now we will see what is the installed capacity in our country. So as of this Here I have mentioned this hydropower scenario in India. This is not the hydropower. This is the entire power. So the whole power in this country, our country, as on 34 to 2020, 370.34 gigawatt is being generated. This is the installed capacity of our country. Out of which, now the central sector contributes for about 93,477 megawatt. From state sector, 1,03,332 megawatt is contributed. From a private sector side, 1,73,549 megawatt is being contributed. So when you take all this thing put together, it comes to 370.34 gigawatt. That is a 1,000 megawatt is equal to 1 gigawatt. See, out of this, 79.8% of the energy is generated using the fossil fuels like coal, lignite, gas, and things like that. And then the share of renewable energy out of this is 70.3% in our country. So India's hydroelectric power potential is estimated at 1,48,700 megawatt at 60% load factor. This is the estimated power potential that which is possible to generate. So, but currently India has got about 197 hydropower plants above 25 megawatt. Each power plant which generates more than 25 megawatt is nearly around 197 plants. And about 9 pumped storage stations and are available in our country. And in this front, India ranks 5th in the world for potential of hydropower capacity. If you take the whole world, 60% of the electricity generation is provided from hydropower plant. If you take countries like Norway, 99% of the electricity produced there in the country is from the hydropower sector. And if you look at this table, you can see the split up details of the power that is generated in our country. If you take the thermal, totally thermal comes around 2,30,600 megawatt, out of which power that is generated from coal-based station is 1,98,525 megawatts. And the stations based on the lignite like Neyveli, around 6,610 megawatt power is being generated. And gas-based thermal power stations are generating around 24,955 megawatt as of now in our country. Then the diesel-based thermal power stations are generating around 510 megawatt in our country. This is the total split up details of these 2,30,600 megawatt of thermal. And if you take hydro, out of all those, apart from 197 hydro portions which are generating more than 25 megawatt, there are so many small hydro portions which are generating less than 25 megawatt. It's coming around at more than 275 power stations in our country, hydro power stations in our country. So out of which around 45,699 megawatt is being generated. Out of nuclear power stations, there are about 20 nuclear power plants in our country, like Kudangulam, Kalpakkam, Bark, and so on. From which around 6,780 megawatt is being generated. From the renewable energy sources, which includes small hydropower projects, biomass gasifier, biomass power, urban and industrial waste power, solar and wind energy. As of now, 87,269 megawatt is being generated. Put together, all these things comes around 370.34 gigawatts. And in this slide, you can see the major hydropower generating units in our country. The first one is Bakra Nangal Dam. You know that it is there in Punjab state. It generates about 1,100 megawatt. And the next one is Nagarjuna Sagar Dam. Nagarjuna Sagar Dam is there in Andhra Pradesh. It is generating 960 megawatt. Koina in Maharashtra, it generates 920 megawatts. Dehar in Himachal Pradesh generates 990 megawatts. Sharwadi in Karnataka generates about 891 megawatt. In Kali megawatt. And if you look at this table, we can see the whole country has different regions like northern region, western region, southern region, eastern region, and northeastern region. If you look at this table, you can see the southern region has got around 288 units, 288 units. Okay, 93 uh, power stations. So each power station can have 2-3 units depending upon the layout there, depending upon the terrain conditions, depending upon the head, depending upon the size of the turbine, size of the generator, capacity generator. Okay, during the design time, so they vary the number of plants. So if you take southern India, there are about 93 power stations, out of which 280 units are there generating 11,034.35 megawatt. If you look at this northern side, 84, which is having around 253 units, but generating 13,000 megawatt. For less number of power stations, but generation is more. Why? Because there are a lot of water available, plenty of water available. There are perennial rivers, but it has got no. Even though there are a lot of potentials available, hydropower potentials available in northern India, like Himachal Pradesh, even West Bengal, and those sites like even northeastern areas, like northeastern areas. Here there are a lot of very big rivers are there, Brahmaputra. Okay? This 1,202 megawatt only is generated out of 40, so number of stations is very less. But we have got plenty of water. There are a lot of under utilized. Okay, the water is underutilized there in hydropower sector. So you see that in the previous slide I showed that there is the hydropower potential is more than 1 lakh. See in the last slide I show you that. See, this we saw around 101,48,700 megawatt is the capacity. This is the power potential available in our country. But only 34,546 megawatt is being generated out of the hydropower stations in our country. So we have to think, right now we have to think about these things. Even though we have got a lot of water, but still then the water is not that much fully exploited for generating this cheap energy. So there are so many reasons behind. It's a sustainable one. The water is perennially flowing. The glaciers are the avalanches which are there in the Himalayan, it's melting, and the rain is available. A lot of water is flowing. But still, then this energy, the sustainable energy, renewable energy, is not that much generated in our country, not that much in this power potential is tapped, even though there is a load factor of about 60% available, but still then there is a lot of gap. See, look at this, 1,48,000 megawatt and 34,000, around 1,10,000 megawatt is still yet to be tapped. Still power stations have to be installed. There is a huge hydropower potential available in our country, but there are a lot of other reasons that we will be discussing all those reasons tomorrow. What are the reasons that are standing as a hindrance or shackles for going for hydropower stations? If you look at this other hydropower stations, even within those, apart from those hydropower stations, there's conventional hydropower stations, there are pumped storage hydropower stations. There is one hydropower station called Kadana, stage 1 and 2 in Gujarat. It is generating, it has got about 4 units. 4 units of each 60 megawatt, generating around 240 megawatt. And Python, It's Maharashtra. It generates around 12 megawatts. There is one unit of 12 megawatt. Nagarjuna Sagar dam in Andhra Pradesh. So it generates around 705 megawatt, uh, utilized using 7 units of each 100.8 megawatt. Kadambari in Tamil Nadu, which is an existing one, which is one of the engineering marvel, the first pumped storage hydropower plant in the Asia. They say that in Kadambari, Tamil Nadu. It is having around 4 units each 100 megawatt, totally 400 megawatt. In Panchet Hill in Damodar Valley Corporation, it generated about 40 megawatts. Maharashtra in Ujjani, 12 megawatts. Biram in Pira power plant in Maharashtra generates around 150 megawatt. Srisalem power station in Andhra Pradesh, it is having around 150 megawatt each. It generates out of 6 units, totally 900 megawatt. And Sardar Sarovar Gujarat power project, it is having 200 megawatt of each unit. Around 6 units are there. 1,200 megawatt is being generated. As presently, this is the biggest unit in our country. 200 megawatt in a single unit, which is the biggest unit in our country. And look at this, the existing one. And these are all the things under construction. If you take Gujarat, Ghatkar, Maharashtra, 125, 2 units of 125 megawatt is being constructed. 2 megawatt is under construction. And Purulia in West Bengal, there are about 4 units being constructed. Each unit is going to offer about 225 megawatt, totally 900 megawatt. And Tehri, stage 2 in Uttarakhand, it will have 250 megawatt of each unit, 4 units, 4 units, totally 1,000. So once it is commissioned, this will be the biggest hydro unit in our country. And then the Emerald in Tamil Nadu, it's also an ongoing construction. It is going to install around 4 units of 135 megawatt. So all these power stations, power stations has got a lot of potential for hydro civil engineers. There are a lot of dams to be constructed, and then water conductor system has to be laid, and your penstocks has to be laid, power houses have to be constructed, railways have to be formed. So there are a lot of water storage and water conducting system available involving so many structures. So it involves right from the survey, right from the acquiring the land, and then going for survey. So there are so many what's going on. So if you have a chance to visit this hydropower stations here in Karnataka, maybe you can just even see some of the power stations close to Karnataka and other places like. You can even visit them and you can learn the various intricacies and interesting points which are pertaining to the hydro power plants. Now we will see what are the classifications of hydropower plants. Hydropower plants are classified based on many parameters, based on the hydraulic characteristics, how the water is flowing, how the water is trapped, how the water is utilized for power generation. Based on the flow characteristics, hydraulic characteristics, the hydropower plants are majorly divided into 4 plants. One is the runoff river plants, second one is the storage plants, third one is the pumped storage plants, and the fourth one is the tidal plants. So in our country, we have all these power plants. The tidal plants are just in a beginning stage in Gujarat. So apart from the hydraulic characteristics, hydropower plants are also classified under different heads. The second one is according to the load. Okay, whether the station is continuously supplying power to the grid, or it is supplying the power in an intermittent way. Maybe depending upon the during the peak time, it can supply power. Mostly, the hydropower plants are the peak load plants. So if you take the base load plants, all the thermal power based plants, Indian based power plants, gas-based, diesel-based. All these things, all these plants are continuously running round the clock, supplying. If you take the load curve, there will be a base area in which there will be a constant need of that much quantity of megawatt all over country throughout its time. So such plants are called base load plants. Normally, thermal power plants are coming under these base load plants. If you take the peak load plants, all the hydropower plants, if you take this morning 10 to 12 o'clock or afternoon 2 to 3 o'clock, 2 to 4 o'clock, and night time. So you can categorize during which when the industries are running full-fledged way, all the heaters, air conditioning, this thing, and all other power plants, electrical plants, and then mechanical machineries that they are really in driving, they utilize a lot of energy. During that time, there will be excess need of power. During that time, in order to supply the excess peaks, the hydropower stations are utilized. See, one of the major advantages of the hydropower plant is it is an instantaneous, an immediate start and immediate stop. So if you compare these hydropower plants, when you compare the hydropower plants with the thermal power plants, thermal power plants takes a lot of time for warming up. In order to bring the power to the grid, you have to wait for about 6 hours, because you have to take the coal. Okay, the coal may be available in the coal yard after bringing from the mining. It may be dumped there. That has to go through so many crushers, like primary crusher, secondary crushers. Then it will go to the mill plant and it will be powdered. Then such a fly ash is just pumped into the boiler. So then it is heated. The steam, the water that is put into the boiler tubes, is heated up and steam is converted, and the steam with higher pressure and higher temperature plays to drive the turbine. So if you take this process, it will take a lot of time to take the base load plant. But in the case of peak load plants, it's not like that. So the water is just at the vicinity of the turbine. The moment you just switch on, the gates will be open, the vanes will be open, water will be leaving and driving the turbine, and immediately the power will be coming to the grid, like the base load plants. So this is another attractive feature of the hydropower plant. So based on the load also, you can categorize the hydropower plants as base load plant and peak load plants. Sometimes, suppose if the quantity of water that is very much used less, if you take one power station in Tamil Nadu, it is having around 1,000 meter head. 1,000 meter head in one of the first power stations in Tamil Nadu. It's available in Singara, that is close to Ooty, but it's the borders of Karnataka, Tamil Nadu border. There is a power plant. It's the first hydropower plant in Tamil Nadu, which is generating around 70 megawatt, having around 11 units. So, but it draws water only less quantity of water is drawn. But the head is more. The water is coming from Glenmorgan. So water is traveling through a penstock pipe. I'll show you all what is the penstock and all in the back. So it travels for about 1,000 meters, and then the power is generated continuously. So such plants are called as base load plants. No, it won't be stopped. Such plants are not stopped. But like if you take other power plants which are not having water available in the reservoir all the time, if the water is not flowing in the river continuously. So if you take the Kaveri river in Tamil Nadu, so we get water from Kudagumalai. Okay, it comes to the Krishna Sagar Dam in Karnataka. Then the water comes to Metu Dam. From Metu, it flows through the entire country. We have got power stations, Metu dams, and then we have got power plants in the across the Kaveri River. At every 10 kilometer distance, we have got a barrage power plant that is called runoff river plants. So in those plants, the water is flowing the Kaveri River only when there is available. When water is available in the reservoir. So Metu dam is not a power dam. It is mainly intended for irrigation. So the water from the wet reservoir is let into the reservoir based on the requirement of the crops, requirement of the by the farmers. Okay, in the higher area, depending upon normally during the month of June, no, it is the water is let out in the river, and for about 3-4 months it will be flowing, and then it will be stopped again during the rain. Maybe it will be coming, but during the month of February, March, like that, no March, from March onwards, it will be shut. So during that time, it may not be water may not be flowing. The power will not be generated. Likewise, there are so many other plants available. Such plants are not a base load plant. They are only peak load plants. So if the plants like Shingara, if it is running continuously, that is a base load plant. Another important peak load plant is our pumped storage. Pumped storage plants are well known for peak load plant that I will tell you in the slides to come. Then according to the plant capacity, you can classify the hydropower plants as idle plants, which are micro category, which is generating less than 5 megawatt. Medium capacity hydropower plant generates 5 megawatt, 100 megawatt. High capacity plant generates 100 megawatt, and super hydropower plant generates more than 100 megawatts. According to the place of powerhouse, no, where the powerhouse is installed. In some cases, in order to utilize the grid, right now there are so many environmental restrictions, no, because of this global warming, forest deforestations, and all these things. The ecological department imposing a lot of restrictions. So you have to get the environmental clearance. Each and every hydropower project has got a long history. So you have to submit an environmental impact assessment to the government. So they may not allow people to go for a surface power. So once you go for a surface power, there will be a lot of deforestation in the forest area. So once you go for underground power plant, okay, there you will go through a tunnel to the area, suitable areas, strategic point, which has more head. So underground power plant, it's the fashion of the day. This is the trend of the day, but it takes a lot of economy, a lot of money involved. So the time period also will be more, but it can be very well utilized as a peak hydropower plant. So according to the turbine specific speed and high specific speed plant and medium specific speed plant and low specific speed plants are available. Now we will see one by one. So being a civil engineering students, it is you will be studying about all these types of power plants, in the water power plant or water resource engineering, and some portion you may even study in hydrology. Okay, but it's one of the major wing. There is a separate MTech branch in this water resource engineering. Water resource engineering, you have to study a lot about this power plants, details and all those things. So now we'll see what is the runoff river plant. Runoff river plants, as the name itself indicates, water which is running in the river, it's made to run away. Okay, just at that time, at the point of time, water is made to run away, run off from the river, just to flow through the conduit for driving the turbine. Okay, you have got a headrest tunnel or a headrest canal. To the headrest canal, it reaches the turbine at a down point. After driving the turbine, it reaches through a draft tube and then it joins the same river. Okay, so it may be sometimes, it may be for a shorter distance. Taking off, water is taken off from the river, main flows of river, just 500 meters, 200 meters, just in the higher head, and then again joining the river course just 200 meters below. This is a small runoff river plant. Okay, in northern India we have got runoff river plant, which is for a longer distance, like 2 kilometers. For 2 kilometers, water is made to run away through a separate canal, through a separate tunnel, and then after driving the turbine, it again reaches the turbine. There won't be any permanent storage. If you look at this slide, runoff river plants are those which utilizes the minimum flow in a river, having no appreciable pondage on its upstream side. There won't be appreciable pondage. There won't be any permanent pondage. That is, there won't be any permanent storage on the upstream side. So your weir or a barrage is sometimes constructed across a river just to simply to raise the water level and maintain the water level at a predetermined level within narrow limits of fluctuations, either only for the power plants or for some other purpose where the power plant may be incidental. So such a scheme is essentially a low-head scheme and may be suitable only on a perennial river having sufficient dry weather flow. So in the previous slides, I was mentioning about one power plant just in the downstream side of the Metur Dam. So I was telling those runoff river plant, barrage power plants across the Kaveri River, they are coming under this category. And look at this. The water is flowing in the river, and then if you look at this thing, you can see there is a regular, sorry, see, look at this diagram. Water is just flowing. Okay, once the water is reaching above the normal reservoir level, water will be spilling through the spillway crust in the weir, and the water will be just joining through the river. Here, just because it is constructed, weir is constructed, the water up to this level will be flowing here. Okay, flowing here, and then it is used here. This is the powerhouse. This is the powerhouse. Okay. So below this there will be a pipe. See here, this is the pipe. So pipe is installed. 1, 2, so many like this. So through these conduits, water will be going inside, driving the turbine, and then leaving the beneath. Okay. So here the excess water is flowing. Here normal water is flowing. So there is no permanent appreciable pondage at all. No pondage at all. There is just a river. River is just obstructed like this. Okay, obstructed like this. Weir scheme. So such plants are called as runoff river plants. So these plants, there are so many possibilities of runoff river plants in places like Sikkim, in places like like Arunachal, because there are big rivers like Tista. Okay, so you can have so many numbers of runoff river plants like this. But still, then we have not gone for that. Around only 1,200 megawatt is only generated. Generated from the northeastern region, even though we have got a lot of water potential available. There are so many reasons behind that we will be discussing tomorrow, day after tomorrow. So this is another type of runoff river scheme. Here you see, this is a head race, river course. The river is going like this. The river course is like this. Okay. What happened? In order to generate power, they put some weight here. They made some kind of intake arrangements just to take in the water, just to pass on to the conductor. This is called pipe, steel pipe. Okay. Here you see, this is not a plain. This is a slope of a hill. Maybe it may have a steep slope or maybe a mild slope. Okay. So from here, water is coming to this powerhouse through the penstock. And then in the powerhouse, the same mechanism, generator is there, hydro generator is there. Power that is generated is taken through a transformer and transmitted for the load centers. And then once it is generated, it leaves the powerhouse, joins the course through the tailways. See, this is the barrage gates available in the Kaveri River. It's a Kaveri River. This is the traffic is flowing on the bridge. Okay. So this kind of barrage gate is another trend. In order to just store water. Okay. Temporarily. And 1 or 2 gates can be opened depending upon the need of the water by the anchored area. Okay, the water that is leaving, stored here temporarily, maybe 1 TMC water. Only 1 TMC is equal to 1,000 million CFT is just generated, stored there, just temporarily, small pondage, appreciable pondage. and then it just leaving this side. The power system is here, it's not shown here. And then water after driving the turbine, it just leaves through the tail race, joins the river. So the barrage gates are mainly constructed in place of weirs. So if you say, you look at this diagram here, this is not barrage gates. Here they have gone for weir. Here they have gone for weir. Okay, this that is also across the river. Here the power plant is not taken to a big penstock. Penstock is only short. Okay, short term runoff river plant. And this is an elaborate one. Okay, here they utilize both the water as well as the elevation. But still then it is called as runoff river scheme. And this is the barrage gates. So this is in place of weirs. Barrage gates are also constructed in the case of runoff river plants. And then we come to the second type of plant, based on the hydraulic characteristics. This one is called a storage plant. In the storage plant, considerable water is stored in the reservoir. Storage plant is essentially having an upstream storage reservoir of sufficient size so as to permit sufficient carryover storage from the monsoon season, the dry summer season. Okay, so water is stored there. So as I was saying that, majority of the dams, our country being an agricultural nation, we have got enormous potential for agriculture. So in the first 5-year plan times, in the budget, Government of India allocated a lot of funds for promoting irrigations, for promoting the agriculture sector. So during that time, they have gone for a lot of dams. So in those times, dams have been constructed primarily only for storing water during the monsoon season. And during the dry summer season, the water has to be allowed through the penstock pipe or through the river, through a proper controlling mechanism. The water is allowed to flow into the river based on the need. So originally, the storage dams have been constructed for that purpose only. Later on, when the revelations, for agriculture revolution, green revelations, white revolution, they say so many revelations. When those revelations came, when industrial revolutions, when it took place, okay, there was a need for more hydropower for producing more from the industries. Okay. So under the circumstances, most of the irrigation dams which have been used as storage dams have been modified. Okay, maybe they means of putting some agreements with the state governments, the power sector departments. They've gone for some kind of agreements with the irrigation department, like maybe like public works department or water resource organizations. So each state electricity board, like they have gone for an agreement with this state sector, and they have put some kind of inserted pipes into the power dam. Sometimes, keeping this future, this sustainability in their mind, the constructors in the original time, just even before the independence, they have embedded some pipes. If you take Bhavani Sagar Dam, one of the dam in Tamil Nadu, it was constructed before it started before independence, and then it was commissioned after independence only. So during that time, one Mr. Kamaraj, he was the chief minister of our state. During that time, what has done? He has constructed with the technocrats. During that time itself, maybe in the days to come, why not? We can go for power generations. So during that time itself, planning time itself, construction time itself, they have inserted some pipes, thinking that in the days to come they may go for hydropower stations. So likewise, they have inserted some kind of pipes in addition to the vents which are available natural, which they have made for allowing water to flow into the river or the canal. So in the latter days, during the 70s, 80s, 90s, okay, people, when a lot of budget had been allocated for promoting hydropower plant, they have gone for just putting hydropower by means of just modified by adding some pipes, putting some, installing some mechanical systems, electrical systems, okay, in a house called as house. That is how a lot of storage power plants came into existence. So if you look at these things, no, they are available. They are made to develop a farm for substantially more than a minimum natural flow. This scheme, a dam is constructed across the river, and the power houses may be located at the foot of the dam. The very first line I saw, okay, it is like a, it is called a storage power plants. If you look at this plant, no, water is stored here, okay, and through the penstock, okay, very small quantity of water. So there will be some control mechanism here. There will be a control mechanism here that is not shown here. Okay, so less quantity of water will be utilized. But in the run of river plants, entire water will be flowing. Here it is storing. During the monsoon season, it will be stored. There during the entire season, it will be utilized. So this is one such panoramic view of a storage power plant. So our most of the hydropower plant, right, storage-based power plant will be like this. No, this is the entire dam structure. Okay, so the types of dams may be classified by different ways. Okay, depending upon the types of it, that is another area. Maybe if it is maybe the days to come, there is any possibility, you can just learn about this much about the dams also. You can have 2-3 lectures for dam alone. Okay, in the dam, you can see this is the upstream side. If you take the water power sector, hydropower sector, huge amount, huge budget is allocated for construction of this dam. Okay, so this depending upon the materials, depending upon the shape, okay, depending upon the way in which it is erected. So the dams are classified by many ways. So most of in our country, we believe in masonry. We believe in masonry, stone masonry. So most of the dams, we have constructed with stone masonry. So it's not as a masonry dam. Even Bakranangal Dam, like this, many dams. If you take this Bakranangal Dam, part of the dam is concrete also. If you take Idiki Dam in Kerala, that's an arch dam. So it will be like this. The arch will be like this. Okay, water will be storing on that convex side. Okay, so this in this dam. So this is a porous area. There, what is permanently stored. Okay, maybe during the rainy season, if it is more, water will be flowing above that. Otherwise, it will be stored here. Suppose if there is a malfunction in this thing, there will be other wind here, this area. Through the wind, the water will be allowing, or this area, this wind, water will be allowed to pass through the power. Bypassing the power, it can pass. So excess water will be flowing over this thing. So for creating storage power plants, civil engineers have to construct huge dams. Okay, so as I was telling, India being an agricultural nation, more than 3,500 large dams are available in our country. So in one of the power stations, which I have not taken, details are not that much clear. See, if you take the Hunda scheme in one area, so all these are all dams. All these dams have been constructed by the power sector, just for generating hydropower. So water that is generated in this dam, the reservoir is coming here and then coming to this contact system, which is the power house. After generating, it reaches here. Likewise, here power house is there generating, here power house is there generating, the power is generating, power is generating, power is. So in order to generate power, okay, if you take this power house for example, okay, water from this reservoir and this reservoir, both reservoirs are coming in. You look at this dam, so water is stored here and then taken. So this is storage power plant. All these things are storage power based plants. Then coming to the third one, pumped storage plants. The pumped storage plant generates power during peak hours. But during the off-peak hours, water is pumped back from the tail water pool to the head water pool for future use. This is one of the interesting features. This is one of the attractive features of the pumped storage plants. See, one of the major issue, critical issue in electricity is it cannot be, electric power cannot be stored in a bigger scale. Maybe in the UPS, you can store power, little power. Okay, it can stand for about 4 or 5 hours. Okay, but for long durations, you cannot store electric power in a larger scale. Okay, sometimes no, in the hydropower plants, if the terrain is allowing for us, what we can do is we can store water. We can pump back the water which is available in the downstream side. Okay, back to the reservoir when there is excess surplus power in the grid. Okay, as I was telling you about the base load plants, during the during the night hours. So when the industries are not functioning, when offices are not functioning, when people are sleeping, when the power utilized the domestic is very less. Okay, so what happens? There will be surplus water available in the grid. During that time, if you want to stop the station, if you put off the station, shut off the thermal power stations, there will be a lot of generational loss. So what they do is they utilize the surplus power which is available in the grid to pump back the water from the tail storage to the upstream storage, to the head storage through the same conduit, the pumped storage plant. So here, the pumped storage plants, while the power is generated, water is coming from the higher end to the lower end, the higher elevation to the lower elevation during the generation time. So when the power is available in the grid, the water which is available, surplus power that is available in the grid is utilized to pump the water from the lower level to the higher level. So by means of that, the power is stored, water is stored. So in turn, it is called as power is stored. That is why it is called as pumped storage schemes. The pumps are run by the some secondary power from some other plants in the system. The plant is thus primarily meant for assisting an existing thermal power plant or some Hydel plant. If you look at this diagram, water from here, okay, when it is generating, flow of water to generate electricity, it is going like this. Power station, it reaches the lower levels. Okay. So when the supply when the power of the grid is more, water is pumped back to the same conduit to the higher levels. Okay. Here in the station, there will be turbine coupled with the pump system. Okay. In the conventional hydropower station, there will be only a turbine. Okay. Okay. If you take the pump, there will be some kind of propeller. Okay. So that's like a pump, like that. That is called as propelling the water. Just suck the water from the borewell. So likewise, the turbine will be on when the water is flowing from here. It will be rotating in one direction. Okay. When the same generator is drawing water from grid, power from the grid, the pump, the turbine will be rotating in a different direction, another opposite direction. The opposite direction. When it is driving in the opposite direction, instead of pushing the water from here, it will just suck the water from this area and then push the water up to the reservoir. So this is one of the attractive features about we have got about 6, 4, 5 power plants existing, and some more power stations are 9 power stations are existing, and some more power stations are under construction. And this is the typical pumped storage power plant. So here is the discharge. Water is just coming through this thing, okay, and then again the water is pumped here, pumped back here, and this is the underground. This is the entire area is killed Below the hill, the power plant is available. Okay. So the power that is generated here is stepped up through a transformer here. Okay, transformer here. So here the power generated is normally 11 kV or 6.5 kV. Okay, 11 kV power that is generated is stepped up here to the transformer, through a transformer. And then the stepped up power is sent through this conduct, a conduit, like a vertical wall shaft. Through the shaft, power cable is taken out, and then from here to the proper switchover system, the water power is distributed. So if you take this thing, this conduit power shaft is constructed for uh, just taking the power cable. Okay, so here the stepped up transformer will be stepping up the power from 11 kV to 230 kV sometimes, 230 kV, sometimes 110 kV, depending upon the deal. So that power big cable will be going, and then through a switchyard, power will be distributed to the transmission system. Which is a typical pumped storage scheme here. This is when the power is generated. No? Power is generated. Okay. So surplus power drives pump to the raised water. So here the power is no when demand is less. Okay. Power to the consumer is reducing, and the power is just sent here. Water is drawn from downstream reservoir, lower reservoir to the higher level reservoir. This is what pumping. Okay, and then when during the demand time, when the demand is peak during that time, I was telling you about morning 10 to 12 or evening 6 to 7 to 9. During that time, maybe high peak during the time, when the power will be more required more. During that time, water will be allowed to flow from higher level to the lower level. Okay, that time it will be acting like in the reverse direction as turbo generator. So during that pumping time, it will act as a pump. Okay, this is the concept behind the pumped storage scheme. See, being a civil engineering student, you must know any hydropower plant. Okay, it has got depends upon the water conduct system, water storage system. Hydropower plants are classified in many different ways. Okay, run-off river plants, sewage plants, like that. Okay, if you take a full-scale hydropower plant, which is an underground one, okay, so it will have this is a hill surface. So below the surface, I was telling about deforestation problems, ecological problems, environmental issues. Government will not allow to destroy the trees, both that. So what they go, they are encouraging people to go for underground power plant. This Paikara ultimate stage hydroelectric power plant, which is also close to Karnataka, in the borders of Tamil Nadu. Okay, there is a place called Paikara. This Paikara is drawn from a river name. There is a river called Paikara River. We got a Paikara Dam in Uti. Okay, the Paikara Dam is known for boating. Okay, one of the tourist spots. So why I am saying about tourism and all now? See, the hydroelectric power plant has got a lot of other advantages. Okay, through the tourism also, people it's generating revenues. Okay, department revenue generating revenues. So through this Glenmorgan forebay, through a tunnel, and then it comes to the stock system, and then powerhouse, then leaving the powerhouse through this tunnel. And then in order to reach the powerhouse, you have to go through a tunnel, access tunnel, about 1.5 kilometer tunnel. You have to go through this tunnel only to this powerhouse. And then there is a cable shaft, and then additionally driven intermediate tunnel. These tunnels are constructed in order to speed up the work in the case of hydropower plants. So now we see the tidal plants. In the case of just 2 minutes. So tidal plants are generation of hydroelectric power or which are recent and modern advancements. And essentially works on the principle that there is a rise in a sea water during high tide period and a fall during the low tide period. You know, high tide period and low tide period. In Gujarat, they have gone for these tidal plants for the first time in our country. So the water rises and falls during the daytime. Water rises and falls during the day. The advantage of this rise and fall is taken in a tidal plant. In other words, the difference between high and low tide level is utilized to generate power. So this is accomplished by constructing a basin separated from the ocean by a partition wall, installing turbines to openings to this wall. Water passes from the ocean to the basin during high tides and thus running the turbines and generating electric power. During low tide, the water from the basin run back to the ocean, which can again be utilized to generate electric power for either direction. Such plants are useful where the tidal range is high. So look at this. These are tidal plants. So this is the ocean. Okay, in the ocean itself, okay, in the seashore, they go for this kind of small obstruction. Okay, in the obstruction, the concrete structure, just in between, they put some kind of erection mechanism, house this turbine. When the tide is rising, water will be flowing. Okay, when it is flowing, this turbine will rotate. So because of rotation, the same concept, generator here, power is going. Similarly, when the level is coming down, tidal level is coming down, the ocean level is coming down. Okay, water from which is in the right side of the basin is flowing back to the ocean. So when it is going this way, again it will be rotated. So both when the tide is coming in and the tide is going out, both the time power can be generated. So these are all based on all those plants like run-of-river plants, storage power plants, you have got pumped storage plants, tidal plants. All these plants have been classified based on your hydraulic characteristics. So based on the operating head, the power plants also can be classified, okay, based on the head, low head schemes, where the water head, as I was telling you, if it is less than 15 meter, they are called as low head scheme. The medium head, in the medium head schemes, the head varies from 15 to 60 meter. In the high head schemes, the head is more than 60 meter. So this is a cross section of the low head, medium head, high head schemes. So here, the storage power plant, water is just flowing from here, only low head. So if it is more head, the head is more, which is called medium, is more than low head, it's called medium head. So if it is utilizing the elevation head, like Singara power in Tamil Nadu, okay, other power houses, Hydropower, utilizing more head, is called high head schemes. So depending upon the low head, high, medium head, and high head, the turbine types also will be varying. This is the low head scheme. Okay. So this is another view of low head scheme, like run-of-river plants. Medium head scheme. This head is somewhat more here. The water is a river, or through the canal it is coming. It is stored here temporarily, and then it is coming. But here on power is here on power. Head will be more. Here, look at this. From at this point, water is going. Head is more. So this is called medium head scheme. So medium head plant, hydropower plant will be looking like this. So you have to look at this in this arrangement. There will be reservoir, dam, intake structure. There will be tunnel, that shaft, wall system, butterfly wall, spherical walls. Butterfly wall normally will be here. With such system, you have the turbine inlet walls, and then you have the turbine, the generator, the turbine, and this is the power house. Room which has got all the electrical, mechanical. Okay. And the case of high head schemes up to 1,800 meters have been developed. The common example of such dams are Bakra Dam in Punjab, Hoover Dam in USA. So another interesting example I said in Singara, that is Paikara Dam, okay, in Tamil Nadu. That is also one of the interesting high-head scheme available presently in here. So another important thing is in Suruliyar, in south of Tamil Nadu. There is a place called Suruliyar Dam, which is another. They say that this is one of the Asia's highest head dam in hydro sector. This is one of the beautiful picture taken from one of the stations in Russia. Okay, this got damaged. The year 2006, no, it is generating around 600 megawatt. Each unit 600 megawatt. 6,000 megawatt is generated. One of the mega hydropower plant. Okay, in Russia, this plant got damaged due to some mechanical fault, some hydraulic fault. This is also a high-grade scheme. So this is another feature of. I was telling you about the Singara hydropower station. So look at this. Powerhouse will be somewhere below this valley. The reservoir is below this point, this area. So water will be traveling, following the terrain and gaining the energy because of the height. That is what wind we call it. Okay, this is the just dam-based powerhouse. Just at the foot of this is the dam, just at the foot of the dam. Storage-based power plant. This is another view of high-head schemes. So, principal components of hydroelectric scheme. A hydroelectric development scheme ordinarily includes a diversion structure, a conduit to carry water to the turbines and governing mechanisms, generator control and switching apparatus, housing for the equipment, transformers and transmission lines to the distribution centers, and a penstock gate. A four-way, sometimes in some areas they call us four-way, a such that, and the other upward entrances may be required. A tail-less channel from the powerhouse back to the river must be provided. The powerhouse is situated at such place that the draft tubes cannot discharge water directly into the river. The tail-less and all these terminologies I have already told. So no two power plant schemes are exactly alike, and each will have its unique problem of design and construction. The choice of a particular type of plant at a given site depends upon various factors such as general available topography of the area. So based on the topography of the area, the head will be varying, the flow rate will be varying, and the availability of other type of power stations in the vicinity. Which power station is available in the nearby, how it can be connected, all these things determines the design. And then requirements of power for industry and the political influence of that area. Okay. So this is the cross section of the hydropower plant inside, how it is inside. It's a transition power line, transition towers. Then the four-bay. Four-bay is nothing but this is a small four-bay. I tell you the concept. Sometimes the main dam will be somewhere, some other point. From this area, the water will be through this intake, some intake area. Water will be taken through a tunnel below this. So a bay from where the water is taken through a tunnel for the particular powerhouse is called as four-bay. Some people call us four-bay. So in the four-bay, there will be provision of intake structure like this. So this is in order to prevent the flow of trashes. So maybe in the water, during the water when it is stored here, there will be a lot of floating debris. There will be wooden logs, dry logs, so many things. So when they are allowed just freely, they will go there and clog the conduit and drain up the turbine. So you have to put some kind of trash rack at the mouth point. Okay. So which is this structure is called as intake structure in order to prevent the debris. So during the overhauling time, when the powerhouse is shut, when the water level is going down, the overhauling team will go and remove all those things and clean them. So the intake structure is an important structure in the hydro power. So this is another intake structure, trash truck area. Already explained about this thing. This is intake structure area. Just see vertical trash rack. This is what quickstock. Quickstock is the pipe, from one dam to the powerhouse. So it will just lay down the surface. Suppose if it is laid on the surface, it is called surface film stock. Suppose if it is buried, it's called as buried film stock. Sometimes no, it will be partially buried and partially throughout its length. Partially it will be buried, partially it will be surface. So partially surface, partially buried also it will be available. Sometimes no, deep in the earth, no, they will make a tunnel and put the film stock inside called as pressure shaft. Okay, this is like in all these erections, no, these mechanical people will erect. No, this is called saddle. So the saddles are constructed by the civil engineers. So if you take this hydropower plant, there are some hydromechanical wing, there are some hydroelectrical wings. Purely civil side also available. So and as an engineer, if you are going to work in a hydropower sector, you have to have knowledge about beyond the civil engineering knowledge. You have to know about how the mechanical turbine works, how the construct works, how is it constructed, how the welding is made. Okay, what is the design design methods, and how the power of this design. All these things, no, you have to know about that. So the pin stock should be located at such a level that sufficient water depth is provided above the pin stock entrance to the forebeam. Sharp bends must be avoided in the pin stock because they cause loss of fit and require special anchorages. So another important component in the hydroelectric scheme is surge tank or surge chamber. So the simplest type of a surge chamber consists of a cylindrical chamber open to atmosphere and connected to the pin stock as close to the powers as possible. When the load is ejected with the powers turbines, the water level in the surge chamber rises and decelerates the flow upstream of it. But when additional load comes, the immediate demand is met by drawing water from the surge chamber, which accelerates the flow gradient and thus accelerates the flow in the reservoir. The surge tank therefore reduces the pressure fluctuations in the conduit pipe considerably. So if you look at this, so they are classified as simple surge tank, throttle surge tank, differential surge tank, multiple surge chamber. So this is what surge chamber. Okay. So this is a pin stock coming from the dam. From the surge dam, it goes beneath the through again some pin stock to the power house. Okay. So this is a surge tank area. So when the power house is stopped, okay, when the gains are stopped sometimes, so water will be returning. When the water is returning, the whole pipe will be pressurized. So there will be water hammer action because of reverse. So in order to reduce the water hammer pressure at this kind of critical portion, at this place of vulnerable point, some kind of well-like structure is available. Okay, sometimes it is excavated in the earth. During that time, it is called a surge chamber or surge shaft. Sometimes it is just above the ground. That is based on the topography of the land. Okay, suppose if it is constructed above the surface, that is called as surge tank. If it is excavated below it, it is called as surge shaft. So this is the simple diagram. This is the reservoir, this is the dam, and this is the power house area. To the power house area, okay, this is the intake structure will be available here. So trash will be removed. Water will be coming through this tunnel or pin stock. At this point, where the angle changes, this is horizontal, this is another vertical sloped one. Here the angle changes. This is the most vulnerable point. Suppose during that, as I was saying, that one of the advantages, meritorious, attractive feature of the hydropower station is it is immediate, instantaneous start and instantaneous stop. Instantaneously it is stopped, the water which was flowing below this thing into the power house, now here it is stopped in the vicinity, but from here the water is still flowing and it will be hitting the water which is already stopped. So there is a possibility of hammering action. Water hammer pressure will be building, and it will be entire shaft will be building with the higher pressure. Because of that, if there is such tank is not available, the whole entire pressure will be from here it will be returning, and then it will try its best to come into the reservoir. So during the course of time, it will eject higher pressure. So at this point of time, this point being having that angle change, this is one of the weakest zone. That zone it may burst also. The power this penstock can really burst if this stop action is going on for continuously during the course of time. It may weaken that point, and there is a possibility of bursting of penstock at this moment. So at this point, it's a normal practice to put some kind of fuse, some kind of fuse plug. You have to just release the excess flow of water, release the excess pressure that is built in the penstock. That is excess pressure that is built in the penstock is just released here. So that is why it is called a surge. Water is made to surge. The electrical terminology we call as surge arrestor. Here it is called as surge tank. Another principal components of the hydroelectric scheme is your turbines, hydraulic turbines. So you study in fluid mechanics. Though you have gone to the fluid mechanics lab, you have studied these turbines. So here this is the reservoir. Okay, reservoir is coming already. The first slide itself I showed that. This is the Kaplan turbine. Okay, vertical shaft, and here this is the bell turbine, high head impulse turbine. If it is coming from higher head, it will be coming through the nozzles. Through the nozzles, it will be heating. It will be going. So this here the shaft is coupling with the generator. Here the water is just gliding through the turbine using the opening called the guide vents. So those are called as reaction turbine and impulse turbine. So these are all the some of the photograph of views of this bell turbine or impulse turbine. Here this portion, water will be hitting through the nozzle. Okay, this was found by the Pelton, that is why it is called as Pelton turbine. This is the Pelton cross section of the Pelton wheel. So all these things are mechanical equipments. But you are studying, being civil engineer, you are studying the hydraulics lab or fluid mechanics lab. This is the reaction turbine. You have got the Kaplan turbine there, Kaplan turbine used, and this is the Francis turbine tube, scroll case. Okay. They showed that. And this is how hydropower function. Now we will see the merits and demerits of hydroelectric power. So once a dam is constructed, electricity can be produced at a constant rate. These are the merits, one of the attractive points. If electricity is not needed, the sluice gates can be shut, stopping electricity generation. The water can be saved for use another time when electricity demand is high. Dams are designed to last many decades, and so on. Hello? 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 Sir, 5 minutes. 5 minutes. The 5 minutes. Just 5 minutes. The 5 minutes. Okay, these are all the merits of the hydropower stations. Now you have the so minimum, no pollution at all, no pollution. Low cost of it. The generation cost is only maximum 2 rupees per unit. Okay, but in the case of thermal power plant, it is more than 5 rupees. So in some places, it is only 50 paise, 20 paise per unit. Okay, for 1 unit, how much you are generating, how much you are paying? Maybe in the for domestic use, you are paying around 5 rupees, 6 rupees, depending upon different. There are different acts available in our country. State to state, it varies. Okay, so less cost of generation, so pollution free, longer service life. Okay, environment benefits like flood control, irrigation, transportation, fisheries, and tourism, as I was already saying. Demerits is, it takes lot of time for clearance. Land acquisition is another problem. Rehabilitation, resettlement. Okay, the time taken for realizing hydroelectric power, sometime maybe even more than 10 years, Whereas the thermal power plants can be finished off within 3 years, the maximum. Okay, these are some of the major merits and demerits. Okay. So apart from that, there will be a lot of climate and seismic effects. All these things now I will be covering in the next classes, placing of geomembrane. There are some case studies available, and for sustainability, I will touch upon some of the case studies. I will tell you next class. Thank you so much. If there is any questions now, right now you can ask. So just now I'll come to the Questions? Any questions? Just going to the anybody would like to please enter your names with the, any questions you have?
So thank you, Johnson sir, for your effective inputs given regarding power plants. So I request students to ask any queries regarding that. Since Dr. Johnson was associated directly with the Hydro Training Institute, he had a lot of opportunities to visit different types of power plants around the state, across the state also. So I ask the students to make use of this opportunity. Queries can be asked now.
Any questions?
Hello, sir. Good morning.
Good morning.
Sir, this is Manish here, faculty. I had just a question, sir.
Yes, sir. Yes, sir.
Sir, leakages are very common in case of dams, right?
Yes,
So,
sir.
like, what strategy does the organization generally practice to ensure to plug this, leakages which do happen on a regular basis?
Yes, sir. Yes. Actually, sir, in the case of there are different types of dams, no. So normally, in majority of the dams, there is a drainage gallery. The drainage gallery is provided in the body of the dam throughout its length. Okay. So the dam in charge, the operation and maintenance people who are looking after the dam, they have to go on daily basis. Daily basis, they have to enter into the drainage gallery. They will be taking readings. There will be some kind of pipes, inserted into the dam, which is having some perforations. Water which is leaking through the dams. If there is any, they will be caught up in those perforated shafts, foundation shafts, as well as the body shafts. Okay, they will be caught up there and they will be entering into the drainage gallery. In the drainage gallery, it will be more than 6 feet height throughout its length. It will be following the profile of the dam. So water which is leaking through the dam, through the body and through the foundation also will come there. And through the drainage gallery in the side, there will be two small kind of channel, small concrete channels, small kind of duct, to be provided. The duct, the water will be flowing. That will be measured. There will be some kind of notches will be provided, and how much height is to what water is flowing. So that is measured, and how much of water is leaking through that is measured constantly. Okay. Suppose if it is not if it is exceeding the permissible limit, the people who are looking after the safety of the dam, operation and maintenance people, they go for grouting. Therefore grouting of dams. Okay, they find out the particular area, and in that particular area, they go for grouting for plugging those any leak, or otherwise, during the off-peak period time, during the overhaul period time, and the water is not available there, they go to the upstream side. They will find out that those holes, some of cracks available in the masonry joints, like that pointing. All those areas will be found, and they will go for rehabilitation. They will go for new pointing. Suppose if the water is still more leaking, they go for different kind of measures. So in Tamil Nadu, we have got one case study in Kadambare. They have gone for geomembrane. It has exceeded 30,000 liters per minute. Per minute, 30,000 liters are passing through the dam. It's one of the grievous situation. It can pass through grievous situation. Okay, they stopped the powers for about 6 months. They shut down the whole powers for about 6 months. They have taken up a special project, special rehabilitation work. They have gone for geomembrane work in order to reduce the leakage. Okay, sir.
Thank you, sir. Thank you. Thank you. Thank you.
Okay, thanks. Any other questions?
Sir, I had one more question. So, I mean, yeah, So when we speak of this hydroelectric power plants, engineers, mechanical, electrical, civil, lot of interdisciplinary things are involved. I think it is a challenge to probably coordinate and come out with successful. So what
Yes,
is your call, sir?
definitely,
Because
sir.
yeah.
Definitely. Actually, sir, the hydropower project proposal is first initiated by the civil engineers. Okay. The proposal, the cost of the project, and then the land selection, survey, everything is done by the civil engineers. And then the project proposal is submitted by the civil engineers. Maybe one or two mechanical, electrical engineers' opinion will be taken up, but it is kind of fully uh, done by the project proposal. Detailed project proposal is prepared by the civil engineering teams, and then it is submitted to the government. After getting clearance, when the power house is started, the whole work is commenced under the head of a civil chief engineer. Okay, under which there will be only civil engineers at the beginning. Okay, only civil engineers, the hydropower project will be there. In that, the entire wing will have only civil engineers. Below that, there will be a lot of contracts. The work will be going on. First of all, you have to go for land acquisition, then the ground setting, and then topography arrangement, survey, and then tunneling, construction of dams, construction of power house one area, laying of the tunnel in another area. So different wings, huge work will be going on. So as the works are going on for about 2 3 years, when it is coming close to that, other installations, slowly other engineers will come in, like mechanical engineers, electrical engineers also will come and join under the headship of civil engineer only. So once that, as long as the power is handed over to the generation wing, under the construction wing itself, so many electrical and mechanical engineers will be working under the chiefmanship of early civil engineer chief. Okay, civil engineer civil. So there had to be a lot of coordination between them. Okay, during the project site, there will be some issues, but that will be automatically solved. Sometimes because of proper coordination, electrical engineers will come to know a lot of civil engineering inputs, and civil engineers will come to know a lot of electrical and mechanical aspects. So they can grow to be a holistic engineer. Okay.
Yes, sir. It needs a lot of coordination.
Yeah,
So
it needs a lot of regulations.
thank you for your overwhelming response for this query, sir. So I think I wish to inform that Dr. Johnson was also giving another lecture on Saturday, which is related to sustainable and innovative solutions for hydropower development. So thank you, sir. We'll wind up the session now due to time
Okay.
shortage. We'll again continue on Saturday's session
Thank you.
regarding another topic, sir. So thank you so much, sir,
Thank you.
for your speech.
Thank you, sir.
Thank you, students. So please be adjoined with the next session with a break of 10 minutes.
Thank you.
Okay. So thank you, Johnson, sir. Thank you, Manish, sir.
Okay.
Thank you, sir. Thank you.
Thank you, sir.
சார் சொல்லுங்க சார். சார் இருந்துச்சு. சரி. இல்ல சஸ்டைனபிலிட்டி நம்ம Yeah.